back to my evidence-based policy, that there's been no systematic, rigorous, notice the quotes around rigorous. Rigorous is now also one of my pet hates, because it's used as a code word to mean something very different than rigorous. But there's been no systematic, rigorous evaluation procedures for projects. That casual, empirical evaluation of projects does not give credible answers, and we need to develop much more rigorous and credible evidence on what works. And the argument has been, and again, just let me pick on the World Bank, if the World Bank had done this on all of its projects in the past, we would now, by now, we would know what works and what doesn't work, and poverty would be history. Sort of very great burden that one could put on the World Bank if it's done its evaluations properly. We wouldn't need the World Bank anymore or anything else. And the question is whether this sort of passion for evidence-based policy is for real, or whether it's just the latest turn of the wheel of fashion. And of course, there's a bit of both. If you look at some of this empirical analysis, I spent a lot of my time doing empirical analysis one way or another. And it's certainly true that if you go back and look at a lot of the empirical work that was done in development economics or in project evaluation, it often was indeed extremely weak. There were correlations between things that clearly had nothing to do with causation. One of the ones I remember, each of us has our own moment on the road to Damascus when you realize that the world has taken a really bad turn. And I remember reading this paper about Chinese railway stations, or I think it was about Chinese railway stations. It becomes sort of mythological in my mind because I was so knocked back by it, in which there was a paper in which it looked at whether places that had railway stations had done better than places that didn't have railway stations. Now, of course, if you think about this, it's just completely absurd. Because places that have railway stations don't have railway stations by accident. There's a railway station there because it needs a railway station. And so, first of all, I just couldn't believe that anyone would ever do this. And then, when they'd done it, they then noticed that there might be a problem and had fallen back on all sorts of econometric tricks, which just made the whole thing worse. So you were left with this total incredible mess of stuff. And I thought, is that really the best we can do? Well, randomized controlled trials, which I will talk about on the next slide, seem to offer a solution to these issues. That they actually establish causality. They offer a solution to the statistical problems of bias, of selection, of omitted variables in the medical literature. It's called confounding. And these arguments have been very successful in the World Bank among foundations. JPAL at MIT and its branches have been doing many experiments around the world. And there's been a great chorus of approval. Here are some of my favorite. Revolutionized social policy during the 21st century, just as randomized trials revolutionized medicine during the 20th. And that expresses a widespread belief that randomized controlled trials revolutionized medicine. I actually don't think that's true, but anyway. And then this wonderful piece of jingoism from the British Medical Journal. Britain has given the world Shakespeare, Newtonian physics, the theory of evolution, parliamentary democracy, and the randomized trial. Can't really do better than that. I wanted to work something about India in there, but you know, I thought I'd get it. But it's just gorgeous stuff. Okay, so let's talk about what a randomized controlled trial is. So you have what I call the trial population. These are the people you're going to do an experiment on. And they're randomly divided into two groups. So the random is a big deal here. Random is an odd word. No one really quite knows exactly what random means or how you know whether it was random or not. But people use it very widely. But let's say you've got a computer random number generator, which of course is usually completely deterministic, but never mind. You've got a random number generator, and you divide this group that you're going to do the experiment into two groups, the experimentals and controls. And the idea of the randomness is that at least if you have a big enough group of people, dividing them up this way, there can't be any differences between the two groups. That's what randomization applies for. So one group is called the experimentals, and they get this treatment, they get this policy done to them. The controls, on the other hand, get nothing, or they get what they would have gotten otherwise. So then the average outcome in the experimental group, so think of this for the moment as like a drug. So you give this drug to the people in the experimental group, and then you measure how well they are afterwards, and you take the average outcome in the control group, and the difference between these two tells us if the treatment works and by how much on average. So you've got these two groups, experimental control. You do the treatment on the experimentals, you get an average for them, and an average for the other group. The groups can't be different because they can't be different because of the randomization. So you're just comparing those two averages, and that tells you whether the treatment worked or not. That's a lot. Gives you this average treatment effect. I want to emphasize average here. In general, because each person in the trial will respond differently to this treatment. I mean, that's a very important thing to realize. You know, if two of us have headaches, and I take an aspirin, and Abhijit takes an aspirin, I might get better and he might not get better because there's differences between people. And if you think of social policy too, I mean, somebody might like to have their PDS turned into cash, and someone might not like. People are different. And what the trial gives you is an average effect. You cannot observe from the trial the outcomes for each individual, but the trial gives us the average for the group. And that's a lot. So I'm going to say some bad things about randomized controlled trials, which you might have guessed. Not building up too much tension here. But I don't want to say ultimately bad things, because it's a big thing to know what that average is. It's just there's lots of other things we want to know too. And that's not everything that we want to know. Doing this randomized controlled trial means you don't make assumptions, and economists are always being accused of making ridiculous assumptions, and we do, but you don't have to make many assumptions to get this to work. You get this absence of bias because of randomization. It's like a true effect, and also it's got to be, this is a causal effect. And for those of you who are social scientists, you'll know we struggle with causality all the time. You don't really know whether the chicken is causing the egg or the egg is causing the chicken, and that's always a problem in correlations and everything we look at. So the fact that the trial establishes causality, because that's the only difference between the two groups, that one group got the treatment and the other one didn't. So that difference has got to be due to the treatment. And that, again, is a huge thing. And when you think the extent to which we've struggled with all these things over the years, that's a huge advantage. So you don't have to make very much assumptions. You get a lot for those assumptions. Big advantage. The question really is whether this is